Hello, I'm Who Are We, and today we're going to be evaluating weighted fishing hooks for seabird bycatch mitigation. Today we're discussing the research article Investigating Weighted Fishing Hooks for Seabird Bycatch Mitigation by Eric Gilman, Michael Musil, Michael Wild, and colleagues. The study addresses the critical challenge of seabird bycatch in longline fisheries, focusing on a promising but commercially complex solution, the weighted hook. The seabird bycatch problem. Seabird bycatch is a major threat to the viability of certain seabird populations, including albatross and petrels, which are among the most threatened group of seabirds. Beyond conservation concerns, bait loss to scavenging seabirds also reduces fishing efficiency. The U.S. North Pacific context. The study is set within the U.S. Central North Pacific tuna longline fishery, where over 90% of the seabird bycatch consists of laysan, or Phobotrista immutabilis, and black-footed albatross, P. nigripes. While a 67% decline in standardized seabird catch rates followed the introduction of seabird regulations, the total number of captures has been significantly increasing over the past decade, exceeding 1,000 annual captures recently, 1,102 captures in 2019. This increase is attributed to rising fishing effort and higher black-footed albatross catch rates, possibly linked to climate cycles and the species' increasing population trend. Albatrosses in this fishery are relatively shallow divers, typically reaching hooks at depths of less than 1 meter. This suggests the highest risk occurs right when the baited hook contacts the surface during setting and when crew bring them near the surface during the haul. Current mitigation and role of weighting. Required mitigation measures in this U.S. fishery mandate attaching a weight of equal or less than 45 grams within equal or more than 45 grams within 1 meter of the hook. The mass and distance of the weight from the hook are critical. Placing a weight closer to the hook reduces the time a baited hook is available to surface foraging seabirds near the vessel during setting, soak, and haul. A weighted hook, where the hook is integrated into the hook itself, presents a potential solution that maximizes the effect of the sink rate to reduce seabird catch, could eliminate safety risks from bite-offs where a shark severs the line and separated weight flies back, and facilitates robust compliance monitoring. It's easier to verify a weighted hook than a sliding weight. Methodology: comparing control and experimental gear. The study involved two main components: a mechanistic study to compare sink rates and an at-sea controlled experiment to assess commercial viability. The experimental design: control branch lines. Use the vessel's conventional gear, a standard circle hook with 45G leaded centro swivel attached roughly 0.75 meters from the hook, and experimental hooks, a custom designed circle hook with 32 grams of lead attached to the shank. The experimental hook had a slightly wider minimum width with 43.5 millimeters to maintain the same gape as the control hook of 42 millimeters. Both hooks had a mass of 14 grams, not including the added lead. Total mass near hook was 14 grams hook plus 32 grams added lead to result in roughly 46 grams total. Crucially, the experimental branch line did not include a swivel near the hook as decided by the fishing crew for simplicity. The mechanistic sink rate study. The goal was to measure the hook sink rate over the initial depth where seabird interaction was the highest, which is roughly 1 meter. Methodology: an adapted bottle test was used instead of the time depth recorders, or TDRs, to avoid TDR mass affecting the hook sink rate and achieve high accuracy over the shallow depth. The measurements were 51 paired trials were conducted to measure the elapsed time for the hook to sink to 85 centimeters. Statistical analysis. The Bayesian General Linear Mixed Regression Model, or GLMM, was applied. 3. At-sea demonstration experiment. Deployment. The controlled experiment was conducted on a Hawaii-based fishing vessel, FV Kaloa, over 13 sets, deploying 18,000 or 1,800 branch lines for each treatment per set. Data. Catch data was recorded the species, treatment, and whether the catch was retained or discarded. No seabirds or other non-species were captured during the experiment. Statistical analysis. A Bayesian random effects meta-analytic regression model was used to estimate the long relative risk of capture on the conventional versus experimental gear for retained and discarded species. The results were sink rate. The mechanistic study conclusively demonstrated that the experimental hook had significantly faster sink rate. The control hook. The mean sink elapsed time of 85 centimeters was 1.6 seconds. The experimental hook, the mean sink elapsed time was 85 centimeters, which was 1.1 second. The experimental hook sank an estimated 1.42 times faster, 95% HDI of 1.37 to 1.48 than the control hooks. This faster sink rate confirms the weighted hook's high potential for seabird conservation gains. Both sink rates, 0.77 meters a second for experimental and 0.53 meters a second for control, exceeded the 0.3 meters a second minimum recommended by the Agreement on the Conservation of Albatrosses and Patrols, ACAP. And the second finding was catch rates and commercial viability. The analysis of 383 captured fish revealed a major economic drawback for the experimental hook. Retained species, marketable fish, there was a significant 53% decrease in catch rates on the experimental hooks compared to the control gear, 95% HDI, negative 75% to negative 25%. The overall pooled effect was significantly less than zero, indicating a lower catch rate on the weighted hook. This substantial reduction in marketable species makes the current design unsuitable for commercial use. Note, big-eye tuna and yellowfin tuna, key commercial species, showed some of the largest log relative risk decreases or lower catch rates. Discarded species, sharks, etc., the overall pooled effect for discarded species showed no significant effect on catch rates. Fisher perspectives. The cruise fisher feedback offered insights into practicality. Building the branch lines was significantly easier with the weighted hook because it eliminated one component, the swivel. The weighted hook did not affect hook setting speed or bait threading. Safety was comparable with equal flybacks on both treatment. However, the crew observed a higher rate of fish throwing or escapement on the weighted hooks, hypothesizing that the added weight caused more tissue damage when the fish struggled. A major practical issue was the experimental branch line lacking a swivel near the hook, occasionally becoming twisted and tangled during hauling. Conclusion and future research. The study confirmed the central hypothesis of the mechanistic component. Placing the weight at the hook dramatically increases the sink rate over the critical 1 meter depth, which strongly suggests the high potential for a seabird bycatch reduction. However, the definitive finding of a 53% reduction in the retained species catch rates makes this specific weighted hook design economically unviable. The authors strongly argue that the future research is a priority to find an alternative weighted hook design that can maintain the conservation and safety benefits while achieving acceptable catch rates. They recommend exploring alternative materials for designs, such as using a non-toxic, denser material to increase mass without increasing hook dimensions. 2. Incorporating a swivel into the terminal end of the experimental branch line to prevent tangling during haulback. And corrodable materials for the added weight to reduce ecological impact from the derelict gear. And thank you all for watching and listening to this video. I was Suarwi. And if you want to learn more about fishing, please take a look into this series that I've linked in the description. It's a book series called A Systematic Approach to Fishing. The most recent book is A Systematic Approach to Northern Pike Fishing, a data-driven guide to pike ecology, equipment engineering, and tactical fishing strategy. Again, the link is in the description, and thank you all for watching this video.